So in this video, we're going to talk about a special case, and these cases are kind of more difficult ones because you can actually miss the integration. So this problem says find the area of the region enclosed by x is equal to y squared and y is equal to x minus 2. Well, my equations are given differently. I'm not given the limits of integration within terms of x or y, because remember, we could do this two ways: type 1 and type 2. Type 2 regarding our y, and type 1 regarding the integration with respect to x. So since this is given in the form of y is equal to x minus 2 and x is equal to y squared, we have, in order for us to get integrate limits of integration with respect to x, we have to get this y squared here equal to some value of x, right? This is y squared. We need y, right? We have y is equal to x minus 2, so we need y is equal to some value. And then we could set the x values equal to each other. So with that being said, we could solve for it. So we have y is equal to x minus 2, right? We have y is equal to x minus 2, well, and we have x is equal to y squared. Well, I just said we can't set these equal to unless we find y. So therefore, if y squared is equal to x, then if I want to solve for y, taking the square roots of both sides, I get y is equal to the square root of x. So let's rewrite them together. Y is equal to x minus 2, and y is equal to the square root of x. Now I could set my two x terms equal to each other. So if I do that, well, square root of x is equal to x minus 2, right? Squaring both sides, I have to square both sides to get rid of this square root here, right? I get x is equal to x minus 2 squared. Knowing what we do about factors, well, x minus 2 squared, we factor this into x squared minus 4x plus 4. Right? We can solve for x on both sides of the equation. So I'm going to bring this x over. So 0 is equal to x squared minus 5x plus 4. This gives us two factors, which is x minus 1 and x minus 4. And that's equal to 0. So therefore, x values is 1 and our x values is 4. So these are our two limits of integration. So if you want to integrate with respect to x, these are the values we use. Now, there's something that interesting that occurs. Remember we said that our limits of integration with respect to x is equal to 4 and x is equal to 1. Well, look here. Well, at x is equal to 1, the limits of integration actually switches. So from 0 to 1, what's the area under the curve? Well, the top function is the square root of x. The bottom function is a negative square root of x. Right? So this whole the area under the curve is not indicative of the actual x values we get. So it doesn't account for this part of the area under the curve, which is something crucial, right? So type 1 with integrating with respect to x is not favorable here. So this tells us that we have to split our integration. Again, the area between the curve from 0 to 1 is actually given by the square root of x and the negative square root of x. Now remember, as we cross 1, then look, the limits of integration switches. We have the top curve, which is the square root of x, and the bottom curve, which is y is equal to x minus 2. So with that being said, we got to split our limits of integration. So if you want to integrate this with respect to x, then this will be the integral from 0 to 1 of, well, what's our top function from 0 to 1? Our top function is the square root of x. So this will be x to the 1/2, the same thing as the square root of x, minus, well, we have a minus the square root of x here. So minus x to the 1/2 dx plus integration from 1 to 4. Well, from 1 to 4, the top function is the square root of x, so that's x to the 1/2 minus x minus 2 dx. So this is how we would integrate this function here with respect to x. So you can see that this limits of integration is much, it's difficult. All right. So let's put everything together and let's integrate this. So the integral is given by 0 to 1 of x to the 1/2 plus x x to the 1/2 dx. All I did was distribute my negative, plus from 1 to 4 of x to the 1/2 minus x plus 2, distribute my negative again, dx. Now, we said that all we did is add 1, so this would be, take an integral, this would be x to the 3/2 multiplied by 2 over 3 plus x to the 3/2 multiplied by 2 over 3 integrated from 0 to 1 plus, well, this is x to the 3/2 times 2 over 3 minus x. The integration of x is just x squared times 1/2 x plus 2x integrated from 1 to 4. Now, plugging in our values, well, if I plug in 1 for x, well, this is going to just become 2/3 plus 2/3. I don't have to plug in 0 because anything times 0 in for x will just give me 0. So this will be minus 0 if we want to put it there. All right. Plus, well, now we got to plug in some values. So this is 2 over 3 times 4 raised to the 3/2 minus 1/2 times 4 squared plus 2 times 4 minus, so this whole thing is going to be minus 2 over 3 times 1 to the 3/2 minus 1/2 times 1 squared plus 2 times 1. Now you could see, let's put everything all together. 2/2 plus 2 over 3 plus so 2 over 3 plus 2 over 3 is just 4 over 3. So we have 4 over 3 here, right? Now, the square root of 4 squared is just 8. So 2 times 8 is 16. So this is going to be plus 16 over 3. Well, 4 squared is 16. So this is going to be minus 4 squared is 16 divided by 2 is 8. So this is going to be minus 8. Well, 2 times 4 is just 8. So this is plus 8. All right, and then we're going to subtract this from this one here. Well, it's helpful to know that 2 over 3, 1 to the 3/2 is just 1. So this is 2 over 3 minus, well, 1 squared is just 1. So this is just minus 1/2 plus 2. All right. Now these go to 0. Negative 8 plus 8 cancel out. So we have 4 over 3 plus 16 over 3 minus, well, let's see, we could do the math for this one. And I'm not going to do it. I'm just going to plug it in my calculator. So when I plug it in my calculator, so let's see, 2/3 minus 1/2 plus 2. That's, I don't have my calculator, so I got to do that in my head. But that should equate to so that's 13 over 6. So that's 13 over 6. All right. So adding these together, that's 13 over 6. So adding these together, well, 16 divided by 3 minus 13 divided by 6, that's 4/3 plus 19 over 6. And if I do these together, well, I got a common denominator. This is 2, and this is 2. So 2 times 4 plus 19, that's over 6. So that is 9/2. So I get 9/2 to be my integration. Now, I just walked the x-axis. What about the y-axis? What if I did type 2 on this bad boy here? So doing type 2, well, if I do type 2, then I gotta solve for my y integration, my y limits of integration, right? So therefore, the original functions, and let me kind of draw a line here. So the original functions is x is equal to y squared and x is equal to y plus 2. No, not x is equal to y squared and y is equal to x minus 2, right? So if I want to solve for my y limits of integration, I got to make sure I got everything in terms of x. So here I have my x is equal to y squared, so I got to solve for x here. So x is equal to y squared, and bring it over 2 on both sides, x is equal to y plus 2. So now I can set these equal to each other. So y squared is equal to y plus 2. So therefore, I can't solve for y on both sides of the equation. So this is y squared minus y minus 2 is equal to 0. If I factor that, well, let's see. So this is y squared. This is y squared. Y squared is equal to y is equal to x minus 2. So then if I factor this, this is y plus 1 and y minus 2 is equal to 0. Yeah, where y is equal to negative 1 and y is equal to positive 2. So if I multiply plus 1, I get a negative 2, and then if I add, I get a negative 1. So these are the limits of integration with respect to y. Now you could actually do it a simpler way and relate the two equations to make sure this is true. So remember we said that if x is equal to 1, then I could just simply plug x in for my y equation. So this will be y is equal to 1 minus 2, which is negative 1. And then we say, okay, well, if x is equal to, well, the other x value found, which was 4. So if x is equal to 4, then y is equal to 4 minus 2, and that will be 2. So the limits of integration are the same here. I just did a long way of solving, but that's the easy way. Now, what about integration? Well, does our y values cover integration? Well, you could see here that we just did. We just proved that at x is equal to 1, we get negative 1, and x is equal to 4, we get 2. So you could say this is negative 1. Up here we have 2. So walking along from negative 1 to 2, you could see that negative 1 to 2 covers our whole integration. So that tells you that setting up our integration, we said this is from, we could integrate this from negative 1 to 2. Right, and then we said it's the upper curve minus the lower curve, right? So what's our upper curve? Our upper curve is actually 2 plus y, all right? So our upper curve is 2 plus y minus y squared. So going along our upper curve right here, so going along the y direction, what's our upper curve? Our upper curve is 2 plus y, or y plus 2. Y plus 2, because remember we're integrating with respect to y. So therefore everything has to be in respect to, so this is not y is equal to x minus 2 anymore. This is x is equal to y plus 2. So going along the y direction, or line, is actually y plus 2. So the upper curve is y plus 2, or lower curve is y squared. So this is 2 plus y, which is the same thing as y plus 2, minus y squared dy. Now we can simply integrate this. So this becomes 2y plus 1/2 y squared minus 1/3 y cubed. Integrated from negative 1 to 2. Now I could just plug in my values. So this becomes 2 times 2, which is 4, plus 1/2 times 2 squared minus 1/3 times 2 cubed. I'm going to also subtract this from, well, 2 times negative 1 is just negative 2, plus, well, 1/2, because negative 1 squared is just 1. So that will give us 1/2 times 1 minus negative 1/3 times, well, negative 1 cubed is just negative 1. Right? So these are the values we subtract. Now we just got to do some simple arithmetic. Right, so 2 times 2 is just 4, so this is 4 plus, well, 1/2 times 4 is just 1/2 times 4 is just 2, minus 2 cubed is 8, so this is minus 8/3. So this is minus 8/3 minus, well, This is -2 plus 1/2 plus 1/3. All right, so this is -2 plus 1/2 plus 1/3. All right, so when I do the math for this whole section here is equal to 10/3. All right, so that will be equal to 10/3 minus my minus sign here. And this is what? -2, that's -7/6. All right. Now if I add these two together, well, this will be a plus sign, so that's 7 over that. 2 times that is that, so that will give me 9/2. And guys, you could just plug these numbers in your calculator to make sure that I'm getting the correct numerical answer. But these two are indeed correct, 100%. I'm sure of that. So we get the same answer, however, two different styles. So that was the emphasis on this video. You could get the same answer, but obviously the type 2 one, where integrated with respect to x, is very much harder. And so that's why it's very helpful to kind of usually in a test, just sketch these diagrams really quick to see what the diagram is telling you. Because actually sometimes the math does not make sense until you see the diagram.